Yeah. So the Kubernetes architecture. So what is the Kubernetes architecture, guys? Container. What is Kubernetes architecture? What is Kubernetes? Container orchestration platform to manage the containers developed by the Google using the Go language. Google donated the Kubernetes to CNCF. Kubernetes first version released in 2015. It is free and open source. What is that, guys? Kubernetes will use Docker internally. Using Kubernetes, we will manage our Docker containers. What is that? So we'll so Kubernetes will use Docker internally. Using Kubernetes, we will manage our Docker containers. Guys, containers. So Docker Swarm versus Kubernetes. We already know the Docker Swarm. So what is a cluster, guys? What is a cluster? We already discussed yesterday. What is cluster? We
Number of
already
nodes.
discussed that. What is cluster? So cluster is nothing but a
Number of nodes.
sorry.
Number of nodes. Group of nodes. Yes.
Guys, speak out, guys. Group of
Nodes.
servers. So what is it? Master node, node or nodes.
Worker.
Very good. Worker, node or nodes. So worker node or nodes. So DevOps engineer or developer will give the task to Kubernetes master. Who will give the task to master node, guys? To develop DevOps guy or developer will give the task to the Kubernetes master. Master node will manage worker nodes. Master node will manage the worker nodes and master node will schedule task to worker nodes. Master node will schedule the task to worker node and our containers will be created in worker nodes. In worker nodes. Using cluster, using cluster, we can achieve high. We can achieve high. So we can achieve high availability. So right, so what is cluster? Group of servers, master nodes, worker nodes. DevOps engineer or a developer will give the task to the Kubernetes master node. Master node will manage the worker nodes. Master node will schedule the task to the worker nodes. Our containers will be created in worker nodes. Using cluster, we can achieve high availability. We can achieve high availability. Please understood. So what are there in the control plane? What are there in the master node and worker node? So control plane or master node or the manager node. So what these are? So API server, scheduler, controller, etcd, worker node parts, containers, kubelet, proxy, and Docker runtime. Right? So how to communicate with the control plane? So how to communicate with the control plane, guys? Control plane is nothing but a master node. So how to communicate? So how to communicate with the control plane, guys? Control plane is nothing master node. Master node or a manager node. How to communicate with the master node, guys? Using kubectl, CLI tool, or web UI dashboard. So what is that web UI dashboard? Open language. You can connect open language. So Kubernetes architecture components. So what is Kubernetes architecture components? What it will do? What it will give? I will show you this. Give me a minute of notes, extensions. I will open the PPT, guys, once again. With the work downloads. Yes. Yeah. So what is this? So this is the Kubernetes diagram. So either how you can connect to the control plane. You can connect to the control plane either UI or CLI. So what are the attributes are there in the control plane? API server, scheduler, controller manager, and CD. So in the worker node, what are the parts? So what is the part? I will tell you. Containers and container, Docker, Kubelet. Kubelet will communicate with each other, and the kube proxies will get the network. Right. So this control plane is communicate with the two network. So how to communicate with the Kubernetes? To communicate with the Kubernetes cluster, we have two options. One is UI, another one is kubectl. So master node manages the worker node in the cluster. It will assign tasks to a worker nodes for the execution. So worker nodes will run the tasks which are assigned by the master node. Worker nodes will run the tasks which are assigned by the master node. Master node means worker nodes in the cluster. It will assign tasks to the worker nodes for the execution. Okay. Yeah. So diagram. So what is the Kubernetes architecture? So when you execute the kubectl command, so you see here, guys. Kubectl is the command mode in order to perform the operations on the master node. Operations on the master node. Okay. The kubectl, when we use the kubectl, it will talk to the API server. API server will talk to the kubelet. API server will talk to the kubelet. Here we can see, guys. So this is the master node. So run the command on the kubectl. So this is the worker node. What this is, guys? This is a worker node. So what master node is doing? What master node, so what is the master node or a worker node? So what is the master node or so execute a command by kubectl, execute a command by kubectl that will talk to the API server. So when you execute the command, right, it will talk to the API server. So what is the command? Kubectl apply hyphen F manifest name, something like a creation of a pod. So once you execute that kubectl, right, it will talk to the API. Execute the command by kubectl that will talk to the API server, and API server will act as a mediator between kubectl and Kubernetes. So API server is the mediator between kubectl and the Kubernetes software. So whenever a request comes from the kubectl, that will be taken care by the API server and will talk to the underlying Kubernetes software. Who is taken care by the request from the kubectl? API server is taken care by the request that are provided by the kubectl. Yeah, that API server act as a mediator between the kubectl and the Kubernetes software. Okay, so whenever a request comes from the kubectl, that will be taken care by the API server. Will talk to the underlying Kubernetes software. If any request comes, for example, I want to create a container in the pod. So we need to provide that request on the control plane. Control plane through the kubectl. Who will talk, guys? API server will talk to the underlying software and will talk to the worker node and where the space is available, where the space is available. So there it will create the containers, right? Whenever a request comes from the kubelet, that will taken care by the API server will talk to the underlying Kubernetes software. Whenever a request comes from the API server and API server stores the inform that stores. So if HCD is nothing but it contains a database. So whatever the file we are executing, right? First it will store it in the HCD. So whenever a request comes from the API server and API server stores the information in the HCD server. HCD server. What is HCD? HCD is a data store in the Kubernetes and it will act as a database to store the details of the Kubernetes cluster. So details of the Kubernetes cluster and whatever the request you comes, right? That API server will talk to the HCD and whatever the information will store it in the HCD. The HCD is the data store in the Kubernetes and it will act as a database to store the details of the Kubernetes cluster. So cluster is going to check that what are the pending tasks are available in, then scheduler is going to assign the task to a controller. What is that? So scheduler is going to check that what are the pending tasks are available in the scheduler. So available in the scheduler, schedule is available, then schedule is going to assign the task to a control manager. This control manager is going to schedule them before going to schedule. Schedule will talk to the kubelet. Who is that? The schedule will talk to the kubelet. So schedule will talk to the kubelet. Kubelet is the worker node agent. It is going to check the health of the node. Kubelet will check the resources available in the node. The kubelet will make sure pods are running successfully and containers are running successfully. What kubelet is doing? Kubelet is a worker node agent. It is going to check the health of the node. It will check the health of the nodes. Okay. It will check the resources available in the node. So for example, you are trying to create a pod in the worker node. So it will check, Kubelet will check is there any space available? Is there any resources available to create the pod in the worker node 1 or worker node 2? Who will check that one? Kubelet will check that one. Okay. So Kubelet will check the resources available in the node. Kubelet will make sure pods are running successfully. So and Kubelet is checking if the pods are running successfully or not. If the pods are not running, it will check it will restart the pods. So Kubelet will create a container on the worker node using the pods with the help of Docker runtime. So with the help of Docker runtime, so the Kubelet will create the container in the pod. So in the pod. Understood. Kubelet will create a container on the worker node using pods with the help of Docker runtime. So Docker runtime is we are using to create the containers. Container is nothing but a runtime of our application. What is that, guys? A container is nothing but a runtime of our application. Guys, now you understood? So what is API server is doing, what kubectl is doing, what scheduler is doing, what controller is doing, what HCD is doing, what kubelet is doing, what Docker runtime is doing. Guys, understood? Guys, understood?
Yes, yes.
Yes, sir.
Yes, right? Yeah. So cluster Kubernetes cluster setup. There are multiple ways to set up Kubernetes cluster. There are multiple ways to Kubernetes cluster. Yeah. So we need to discuss this pod also, right? Let me discuss this pod. Yeah. So we discussed about the API server, scheduler, and controller and etcd. Right. So what is a Docker engine? So to run our containers, Docker engine is required. Container will be created in the worker nodes. Okay. So where the containers are created? Containers are created in the worker node. That's the reason we did Docker runtime. What is a container? It is a runtime instance of our application. It is a runtime instance of our application. What is pod? Pod is the smallest building block that we will create in Kubernetes to run our containers. What is pod, guys? Now you understood what is pod? Pod, it is the smallest building block. What is a pod? Pod is the smallest building block that we will create in Kubernetes to run our containers. So pod will create logically to run our containers. It is the smallest building block that will be created in Kubernetes to run our containers. Docker containers will run inside the pod. In Kubernetes, Docker containers will run inside the pod. Pod is a smallest building block that will create in Kubernetes to run our Docker containers. Okay, guys, understood?
Yes, sir.
Guys, understood, right? Very good. Now you understood the. Now you understood the container pod, container, Docker run, and what is the kube proxy? So kube proxy is there, right? So this is the kube proxy. So what is the kube proxy? What is the kube proxy? It will provide network for Kubernetes cluster communication. It will provide the kubelet. Kube proxies provide the network for Kubernetes cluster communication, master node and worker. So how you can communicate with the master node and worker node? It will communicate through Kubernetes proxy, kube proxy. Okay, guys, understood? Very good. So what is that? Kubernetes clusters setup. So how to set the Kubernetes cluster? Guys, I think Ramkrishna, Ramki,
Sir.
yeah. How you set up the your AKS cluster? What is that? Self-managed cluster, and the second one is provider managed cluster. So self-managed cluster and provider managed cluster. Paint, guys. So paint. Yeah. So this is, for example, what this is? This is a Kubernetes, right? This is the Kubernetes cluster. So this is the Kubernetes cluster. This Kubernetes cluster will set up in two ways. So the Kubernetes cluster will set up in the two ways. So what those are, guys? So we'll set up two ways. Set up. This is also set up. So we can set up the, so Kubernetes cluster will set up in two ways. One is, guys, one is self-managed. The other one is
Only I can do.
provider. What is that? Provider managed. What is self-managed? What is provider managed? Whenever the cloud introduces, right? So that time there is no container concept. So that time only virtualization and physical and virtualization, right? So once the containerization created, right? They created a service called as a containerization service called a ECS. What is that, guys? Elastic container service. So what is elastic container service, guys? So elastic container service is nothing but they created the VM. What is that? They created the virtual machine. So in that virtual machine, so we need to install the container, right? Docker container. We need to install the Docker container on the virtual machine. So we want to, if you want to install a container service, we need to first we need to install the VM, then we need to install the container service, right? So they already predefined this environment, and they provided as a, what they have provided, guys? They provided as a EKA, ECS, Elastic Container Service. Elastic Container Service. So same like as a after Kubernetes came, right? They provided as a service called as a EKS. What is that? Guys, tell me. Elastic Kubernetes
Service.
Elastic Kubernetes Service.
Service.
They predefined the Elastic. They predefined the EKS, and if you click this service as it will automatically create the infra. It will automatically create the infra, right? What is that? aws.amazon.console.com. So in sign into the console. So once you sign into the console, right? You want to, they are provided a service is called as a ECS and EKS. ECS and EKS. What is that? GlueJTech 29. I am connecting to the AWS console. Once I connected to the AWS console, I will show you what are the services they are providing. What are the services they are providing? I will give you that MFA 165636. Okay. So this is the MFA for authenticating. What is the password? Yeah, this is the password. I need to set the MFA, right? What is this? Change it up. So 165, sorry, 533851. Okay. Yeah. So here they created a service as a ECS, Elastic Container Service. So in the Elastic Container Service, it's a predefined environment. They provided the, if you create the Elastic container, right? Yeah. Amazon EKS makes easy to deploy, manage, and scale Docker containers running application services and batch processing, right? So this is EKS. But once the Kubernetes is developed, they provided a service called as a EKS, Elastic Kubernetes Service. So if you click the Elastic Kubernetes Service, whatever the setup we are manually building, it will automatically provided. So what are the provider AWS provider managed cluster? So provider managed cluster is nothing but a cloud provider will give a read mode cluster. What is that, guys? So what are those providing? AWS, EKS, Azure, AKS. The next GCP, GKE, IPM, IKE, Oracle, OCI. Okay. So these all are the provider managed Kubernetes cluster. What these all are? These all are the provider managed Kubernetes. So who will provide? Amazon provides the EKS, Azure provides the EKS, GCP provides the GKE, IBM provides the IKE, Oracle provides the OKE. Right? This is the provider managed Kubernetes cluster. If you click the create a cluster, it will ask in some questions and it will automatically create the Kubernetes cluster, EKS Elastic Kubernetes cluster, right? So this is the provider managed. Who will manage this? We don't need to install from scratch. So who will provide the solution? The provider, cloud providers provide the solutions. What are those solutions? Those solutions are AKS, AKS, EKS, GKE, IKE, OK. These all are the provider managed solutions. So if there any issue with the installation and managing, who will take care of the installation managing? The installation and management. So
Cloud
is
providers.
the installation and the management will be taken care by the providers. The installation and the management will be taken care by the
Cloud
providers. Guys,
providers.
understood? So we don't need to bother about this. So self-managed. So what is self-managed, guys? Self-managed is nothing but we will create our own cluster. What is that, guys? We will create our own cluster. Our own cluster. So our own clusters, we need to set up from scratch our own manually. So this is installation and management will be taken care by the provider manager. Okay. So what those are self-managed? So self-managed containers are mini cube. What is that, guys? Mini, guys, read out. Mini cube. So mini cube is a single node
Single node
cluster.
cluster.
What is that, guys?
Mini Cube.
Yeah. So Dev environments are using Dev ENVs are using the single node clusters. Who will use these, guys?
Dev.
Dev environments will use the single node clusters. So the next one is Minikube is a Minikube. This is one VM. In this VM, we installed the master node and we installed the worker node. So both the master node and worker node will be installed under the one instance is called it as a mini cube. What is that, guys? Installed under is called it as a mini cube. Single node cluster. What this is, guys? Single node cluster. What is this, guys? Sir? This is a single node cluster mini cube. They call it as a mini cube. The second one is what is the second one, guys? The second one is it is a Kubedium. What is that, guys? Kubedium. Kubedium is the multi-node cluster. What is that, guys? Multi-node, multi-node cluster. Kubedium is the multi-node cluster. So we can create same way. This is the multi-node cluster. What this is, guys? This is a what this is, guys? This is a multi-node cluster. So multi-node cluster. Guys, understood? This is a multi-node cluster. So multi-node cluster means we need a one control plane and one or more worker nodes is called as a multi-node cluster. So multi-node cluster will be created by using
I have a window outside.
by using Kubedium. Okay, Kubedium and single node cluster will be creating through Minikube. What is that, guys? Minikube. So provider managed and the self-managed. Guys, now you understood, right? The self-managed and the provider managed. So how you can set up the mini cube? So how you can set up the mini cube? You can set up just so install mini cube is very easy. So in this class, what we will discuss? So we'll discuss about the AWS EKS cluster setup. What is this, guys? So EKS, AWS EKS cluster setup. So what we need, guys, for the EKS cluster setup? So what we need? We need a, we already know the pod, right? Pod services, pod services, namespaces. The fourth one is replication controller. What is replication controller? So replication set, replication set, daemon set, stateful set, stateful. What is that? Pod service namespace, replication controller, replication set, replication set, daemon set, deployment. What is deployment? The 10th one, config map under secrets K8s with the ingress controller and K8s volumes. We already discussed about the Kubernetes Docker volumes, right? We will discuss about the K8s volumes. Helm charts, Helm charts. 14th one is ELK setup log authentication. What is that? So log aggregation. So 15th one is RBAC and 16th one is K8s web dashboard. Web dashboard. So web dashboard is nothing but it will show the open line. So will show the open lines configuration. Guys, understood? So what we will discuss? So we will discuss about the cluster in the cluster setup that Kubernetes. So cluster setup. So we'll discuss about the EKS cluster setup. So cluster setup will show you tomorrow. So where I posted the cluster setup, GitHub. Okay. Hmm. Guys, one. Yeah. The AKS cluster setup will be so in the AWS DevOps material, the cluster setup will be created, guys. Ansible, Kubernetes, yeah. In the Kubernetes, so we discussed about the EKS setup, guys. What you guys can do, you both are sit together and create the EKS setup. Okay, just to follow the steps, it will automatically install, guys. No need to create anything. So if you are not able to create the EKS setup, right? I will show you how to create the EKS setup. Or we have a video in the YouTube, guys. You guys can watch this video and to set up the EKS cluster. Okay.
Hello, sir.
User technologies. Yeah, yeah. 1 second. In the playlist of iMac ID, I think. In this iMac ID batch. Yes, guys. AWS EKS tutorial, Kubernetes on AWS. Create a EKS step by step. You guys can watch this recording. Okay. You will understand the how to set up EKS on your guys. EKS set up on AWS, AWS cloud. Okay. Guys, please prepare the EKS setup on your AWS console. Then we'll show you what is a pod, these. Okay. So we'll discuss. So we'll discuss what is a pod, what is a service, what is namespaces, what is replication controller, replica set to daemon set, stateful, deployment, config map, secrets, ingress controller, Kubernetes volumes, Helm charts, EKS setup, R backup, Kubernetes web dashboard, EKS, right? Once you connect, so once you install the EKS setup, then you can try to install OpenLens on your Windows machine. Windows Vision. I will show you how to set up the how to connect the EKS from your machine. Okay. I will show you how to connect. I will show you how to connect. So this is the images, open lens. So this is just a software, guys. Yeah. So once you set up the EKS, right? Yeah, this is the parts, deployments, so stateful set. So whatever we discuss it, right? So it will show network, ingress, so everything will show. Your parts also will show. You can manage your parts from OpenLens also. So what we need, guys, we need a config map. What we need? We need a config map to connect this OpenLens. Connect to this OpenLens. 1 second. So this is your open lens, right? For example. So this is your open lens and where you install the EKS, you install the EKS on here, right? So for example, you install the EKS on this here, right? So you want to connect this EKS on this EKS on in your Windows machine, on your Windows machine to operate the Kubernetes cluster. So what is that? Open Lens is the software to install in the Windows machine and need a config file to communicate between EKS to Windows. Communicate between EKS and the Windows, guys. Yeah. So once you done the setup, right? I will show you how to install the OpenLens and how to connect the OpenLens. I will show you. So this will connect on each and every time. If we want to connect OpenLens, definitely we need to we need to get the config file, kube config file from your EKS to your Windows local machine. Then you can open that OpenLens. Okay, understood, guys? The kube config file will be changed each and every time. We need to get that. We need to copy that and we can need to paste it in the that open lines. Okay. Yep, guys. So we'll continue from tomorrow. So if you are unable to set up the EKS, right? So tomorrow we'll show you how to set up the EKS, guys. Okay. Thank you.